Alright, in this video I'm going to do the remote lesson plan for day 1 for AP Physics 1. So here we go. We're solving for the circled variable on each one of these things. Alright, here we go. So the very first one here, we're solving for A. So the first thing I actually want to do is move Vx 0, or Vx sub naught is another way you can say that. Naught means 0. But anyways, we're going to move that over. Currently it is added to AT, and we are going to therefore subtract it from both sides. So what we're going to see here is we have Vx. By the way, my favorite way to represent these is to call this one Vi and to call this one Vf. And that's actually okay on... Alright, so yeah, there we go. Vx minus Vx 0 equals AXT. I may lose the x's after a while. I get tired of writing all this. All that's telling you is that these are all in the same direction. Other than that, this is an equation you should have seen before in honors physics. All right, last thing here, we need to solve for a, so we're going to divide both sides by t. And that's it. Just totally make everything clean and done here. And that is it. So that's the solution to number 1. While it's on the screen here, I'm going to go ahead and do number 4. So what I was trying to indicate here is don't worry about this thing in the middle. We're just saying A equals F over M, and we're solving for M. By the way, the arrows just indicate that these are vector quantities. Other than that, nothing. There's no mathematical thing that makes this more difficult here because of the arrows. I'm just going to rewrite the whole thing. Okay, a very common mistake that students make is they initially look at this and say, okay, I want to solve for m, so I'm going to divide both sides by f and be done. But what that gives you is 1 over m equals a over f, and then you'd have to take the inverse. My personal favorite way to teach this is to move the m over to the other side, so it is now in the numerator, so we multiply both sides by m, and now we can clearly see that the next thing that we need to do here is we need to divide both sides by a in order to solve for m. So m equals f divided by a is the correct answer here. Yeah, that cancels out. Yep. Okay, and if you wrote all the variables, great. If not, that's fine too. Let's scroll down a little bit here. Now, the reason why I scratched this out is if that term is present, then you have to use a quadratic to solve for t, and I didn't want to make it that messy because then you'd have to use like the quadratic equation and substitute all the variables in. We're not trying to go crazy like that. So anyways, just like I said before, I kind of like using i's and f's. So the 0 here is saying the position at time 0. This is the final position here, and we are solving for t, and I'm just going to scribble out that little x there because we know this is all happening in the x direction, so I'm not going to carry that along. Okay, so we're solving for t. First thing I'm going to do is move this xi over. And to do that, I'm going to subtract it from both sides. And so we're going to have xf minus xi equals 1/2 at squared. Now, to isolate the t, we're going to need to move the 1/2 a over to the other side by dividing. Okay, and when you divide by 1/2, that is the same as multiplying by 2. So put 2xf minus xi. Don't forget to put some parentheses around that. All over a equals t squared, and then need to square root all of this to solve for t. So that'll be your final answer there. I'm out of space, so I'm just going to circle that and call it good. All right. Now, I did try to make this a little spicy, so yeah, we're solving for the variable in the denominator here. All right, so let's do that. Like the previous one, I'm going to move that out of the denominator. Actually, this really is not that spicy at all. And I'm going to ignore the absolute value sign there. That's because gravity is always an attractive force, and so you just have to understand, hey, this is the size of that force. It doesn't tell you the direction of the force. So anyways, if g r squared equals g m1 m2, and last step here is we need to divide, actually not the last step, divide by gravity. And note that g is a subscript, not a g representing 9.8. That's just saying this is the force of gravity. Okay, so that is going to cancel out gravity there. And then the last thing we need to do is square root both sides. And that will be our final answer here. Not rewriting everything because I'm kind of running low on space there as well. All right, and let's go ahead and take care of this one. So we got to solve for the acceleration here. Yep. So let's move Vx0 over there. You know what? Let's just replace this. That's the initial. That's the final. And this is initial, and that's final. And I'm just going to squiggle that out because we know it's in the x direction. Okay, cool. So let's move the VI over. So we're going to have subtract. Oh, look at that. All right, so here we go. Subtract VI squared from both sides. So VF squared minus VI squared equals 2AXF minus XI. And are we solving for 8? So that means we need to divide both sides by 2XF minus XI. Don't forget the parentheses here. And yeah, other side as well. 2XF minus XI. 2 cancels, that cancels. That solves for 8. That's what we want. A equals VF squared minus VI squared. Note, this needs to be written this way. You can't put the VF and the VI together and in parentheses and then square it because that's something different. That is not algebraically equivalent to what it's written here. So that is that's final answer there. All right, I'm going to totally ignore the greater than, less than, equal to kind of thing that's going on here. We're just trying to get at force of friction. By the way, this is the it's kind of an icky way of combining static friction and kinetic friction, because they just say, hey, here's the coefficient. But basically the idea to calculate friction, you multiply the coefficient times the normal force, and we'll review all that stuff, but we're just trying to do algebra today, so there you go. All right, so we're solving for the coefficient, which simply means we just need to divide both sides by the normal force, and we'll be good to go. Look at that. Physics can be easy. It's not always easy, but it can be easy. All right, solving for spring force this time, or no, we're using the Hooke's law spring force equation. All right, and I'm going to ignore the, yeah, um, we just need to move the delta x over and the negative, and we're golden. And the negative really doesn't mean a whole lot other than the direction that you stretch or compress the spring, the force is exerted in the opposite direction. That's what that means. We talked about that previously. But yeah, we need to divide by negative delta x, divided by negative delta x, and that cancels. Great. So literally that's it. K equals F S. Maybe throw a negative sign in there. Delta x. Woohoo. Okay. All right, solving for the V in the kinetic energy equation. No crazy stuff going on here. So we just need to move the 1/2 and the m over to the other side. So we're going to divide by 1/2 m, divide by 1/2 m, and that's going to give us 2k over m equal. Remember, when you divide by 1/2, it's the same as multiplying by 2. You multiply by the reciprocal. I think it's how the math teachers say it. And that equals v squared. So what do we need to do? We need to square root both sides, and that gives us our answer. Okay, solving for the v in the centripetal acceleration formula, which we will eventually get to in this class. So we need to get r over to the other side. So RAC equals v squared, and then we're going to square root both sides. That's it. That is done. All right, and squiggle that guy out right there. We're solving for the F in the work equation, so we need to divide both sides by d cosine of theta. Okay, so what we end up with there is force equals work divided by d cosine of theta. All right, so mastery of algebra is something that is very, very helpful for being successful in AP Physics, and so that's why we're just practicing doing some of this. If you have any questions about any of this stuff, let me know.